Hello and welcome to another free code session. My name is Jason Bach, and I'm going to do a little bit of something off the beaten path, so to speak. Most of my videos are about projects that I'm working on or areas I want to explore, so I guess that would be kind of in that realm. But if you're looking at my Visual Studio window here, you can see the name of the project here is a little bit of an indicator of what I'm going to be getting into here. This is code that I found in a production system. I won't say where, I won't say who did it. I honestly don't know who did it. Everything's been stripped out of it in terms of any identification. This is just meant to illustrate what I find is a problem in software development to this day, and I'm not sure it's getting any better. It's okay to make mistakes. I make them all the time. In fact, when I record videos, I find it funny as I'm watching them, the mistakes that I do make. In fact, in one of the videos I just made, that I think it was the one that is previous to this one, there was a mistake I made in putting a constant in twice, and that caused a key to be inserted into a dictionary twice. Stupid mistake. People make them. The way that I coded at the beginning of my career, if I looked back on that code, if I could find it, I'd hang my head in shame. I know I would. I look over this way, because one of my bookshelves is over there, and that's where my master's thesis is stored. And I look at the code. It's atrocious. It worked. Something to be said for something that works, but I know if I wrote that now, it would be so much better. Yeah. So I am not one here sitting on a pedestal saying I never make a mistake when I code. I code the same way now as I did 6 months ago, a year ago, 5 years ago. But that's kind of the point I'm getting at, is we should, as developers, grow continuously over time in terms of how we write our code. And I'm focusing in on that part because I feel as though in our industry we get so caught up in terminology and features and new gizmos to use. And while that's okay, the latest phrase in the last couple of years has been microservices and cloud native and Kubernetes. And it may sound like I'm saying those with disdain. I'm not. The concepts and the ideas around them have merit. But the problem is everybody gets so wound up on those, and we have to have so much discussion and so much effort put around these things that we're not looking at what we're actually putting into our containers and what we're putting into production systems. It's almost become development is easy. We can buy more hardware. We can get more memory. And it's frustrating to me. It's really frustrating me. I saw a video recently. I will get to the code, don't worry. I saw a video recently, and I'll try to remember to put a link in the video to the video in the description, by Jonathan Blow. I've mentioned him before. I find him to be, at times he can be very thoughtful. He can be very perceptive, and he definitely has coding skills. There's no doubt about that. The Witness is probably one of the best games I've ever played. I thoroughly enjoyed playing that game. And when he has that mentality of thoughtfulness, when he has a mentality of introspection and observation of things, he's very interesting to listen to. When he goes off on rants and just kind of speaks his mind, I turn off his stream. I find it rather worthless. I mean, I'll be honest, it's rather worthless to listen to. I am not a fan of JavaScript. I'm not, and I felt like for the last 5 years that saying that you felt like there's problems with JavaScript was verboten. You couldn't say that because everybody's doing JavaScript. Everybody, it's the best thing humanity has ever created in software, which blows my mind. I find that the language is lacking, to say the least. And now that we no longer are constrained to having to use JavaScript in the browser, or that we can minimize it, and over time that should get to be even less and less, we can pick other languages. But I will say this, whenever I talk about things like WebAssembly, I'll tell people, if you feel like you're productive in JavaScript, if you feel like you can build awesome systems and applications that your users love, rock on. I'm not going to tell you that you're wrong. I'm not going to tell you that that you're making a mistake, that you're doing bad things. That's not true. I started in Visual Basic out of college, and the definition of VB as being a toy language, it's not serious. It doesn't have this feature. It's drag and drop. It's all, you're not really understanding, languages. All these other criticisms of it. And yet, I could build something rather quickly and get it out to end users. Now, that doesn't mean it's perfect by far. Don't get me wrong. There are definitely things that I felt were, as I learned more, were limitations. But at the end of the day, if you can build something that works, that is somewhat of a hard argument to get around, Now, what I'm going to show you also works in the sense that it's in a production system. It is a piece of code that made it and is being used in somewhere that somebody could actually hit. Again, I won't say where. But it doesn't mean that it's good. And the fact that this got to this point, the fact that somebody actually wrote this code, somebody somewhere had to write this code, type in all the characters, submit it, hopefully as a PR that somebody was reviewing, or maybe nobody was reviewing this and it just went in. But maybe somebody reviewed it and rubber stamped it and said, looks good to me. I don't know. But here we are. So I'm going to build from, just kind of show you that what's there, and then we're going to benchmark that against what I think is a slightly better way. Okay. So, as I was going through the code, this is kind of what I found. And as I told a couple of my friends later, let me make sure of the line count here. How much do I have selected here? I thought there was a way in Visual Studio to tell you how many lines you have copied. I don't know. This is what? Line 8, line 31. So what are we talking about here? 22, 23. It's early. I'm just starting on the coffee. But I said, I don't know if I've ever seen as much badness in a piece of code this small in my life. There's so much that's just not good about this, and that's being nice. Okay. So let's start. Apparently they need to parse a GUID. Why, I don't know. I found out later. We'll get there. But they pass in a string value as a GUID. So we look to see if it's null or empty or null or white space. first looked at this and said, why won't you just use this? Or just this? This was been around since 1.0, and then they added is null or white space in 4.0, I believe. But why do both? Like, that's weird to me, right out of the gate. Not just weird, I'd flag that immediately and say, no, do one. But it gets worse. Then we enter a try block, and we call try parse on GUID. We don't do anything with the result value. We just see, could it be parsed? And if it is parsed, yes, we create a task to return true, and we await this. If it's not, we're going to do a new task that returns false. I could not wrap my head around this at all. I stumbled like I am right now talking. I couldn't believe when I saw this. I'm like, this is insanity personified. How do you describe this? How do you say it to somebody? Just say right here, return GUID try parse. Don't make it an asynchronous method. Nothing in here is asynchronous. Don't force async on top of a synchronous method. If you have CPU-bound work, leave it to be CPU-bound work. Let the caller determine if they want to schedule that on different threads through tasks, if they so desire. But this is not asynchronous work. And just to return a Boolean value, wow. And then they do a catch block. Catching the general exception type, which is a huge no-no in my book. You rarely, if ever, do this. And you definitely don't do this in every single method that you have. I have a presentation that I've done in the past on exception handling in .NET, and I have all these links to all these sources in .NET and otherwise, why doing something like this is a bad thing. Okay? You don't know what exception has happened. You don't know what's gone wrong. And you can't catch every exception type in .NET either. You can't catch a Stack Overflow exception. I can't remember, there's two others off the top of my head, but I can't remember their exact names. But there are ones that you cannot catch. Okay? So this is just wrong to me. Plus they catch grabbing the exception, but they never do anything with it. Which you could say, yes, a compiler may optimize it out, but why even write your code that way in the first place? You just return false. So if you got an out-of-memory exception, we'll just return false. But it gets better, if you can believe that. This is passed in through dependency injection into service. Now, I'm not going to get into DI and whether that's a good thing or a bad thing. I generally like it. I think it has its merit and its worth. But the point is that this service class needs the parser. Okay, because, and yes, I'm not kidding. What it's going to do is try to parse the GUID again and doing the same is null checks on string, passing though the value into try parse GUID, doing it asynchronously and returning false if there is an exception. It floored me. It utterly floored me. I don't know what I could even say about this. Okay. Now you're wondering, what is this get data name or get data? We'll get to what those are for a moment. Those aren't necessarily bad things, but we'll explain what that is in a second. Okay? Because they're using the service controller. The service controller gets a reference to the service. And what it's doing is a typical controller that you would have in an ASP.NET application. This is essentially a get method to get some kind of data related to something, some domain entity, whatever you want to call it. Okay. So the real method does a little bit more than this, but I kind of wanted to focus in on this stuff. Again, we're just going to check is null or empty this time. Okay. Then we're going to see if we can parse it. And I was wondering when I first saw this code, I'm like, is somebody actually going to really parse it into a GUID? And sure enough, that's what they do. If the value that you're getting is a string, but it really contains a GUID, then what we need to get is the name from that identifier. So you can think of a database that has a table that has an ID as a primary key and some name related to that ID. That's what they're trying to find. And yes, this is the point where now you actually call GUID parse. This is also technically an asynchronous call because this really went out to another service. But for this point, I just kind of ignored that. And then you actually go get the data. All right. Again, my jaw was kind of just hanging at this point. And it's such a simple thing. Like, you may look at this and go, well, yeah, this is really bad, but how bad is it? Well, I'll show that in a moment. I'll show that through better, Getty's sake. Now, when I say better, as soon as you talk about optimizing things, there are people that will look at it and go, well, why don't you do this and why don't you do this? And that's awesome. That's actually what I think people should do. Reviews are not meant to be critical of people. They're not meant to ridicule people. They're not meant to make fun of people. They're meant to be critical of the code, the implementation, and to be constructive about that criticism. To say, hey, you don't need to do all this. This is all you need to do. If what's coming in could be a GUID, then use try parse, pass in the successful value if you could do it, then get the name, and then call get data. That's all you need to do. I once did a review where I saw somebody implement a method, and for some reason the way they did it is they used all this system link expression stuff where they were building expressions on the fly, compiling them, and then executing them. And I said, why are you doing this? All you need to do is like 2 lines of code. Oh. I mean, that one floored me because why would you even think of going down a link expression route, you know? But it's okay to say that, you know, we can do better here. And so that's what I'm trying to get across here is we can do better. How much better? Well, I wrote where is this? A class that has tests for benchmark.net. Okay, so if you've never used benchmark.net, I've mentioned it in past videos. It's a great framework to do analysis of your code. So I have one way of doing it, the current way, and then I have the proposed better way. Okay, and so I ran this. I'm not going to run it now. I ran it, and these are the results. So it's an order of magnitude faster, and it takes, what is that? 486, 720. It's approximately around 3 times less memory. Now, the naysayers among you might go, well, that's like 2 microseconds compared to 0.2 microseconds. A human being can't perceive that, and that's true. But that's also time that's completely being wasted in the application for no good reason. None. And yet it's there. So that little paper cut is in the app all the time that this method is being called. And there's no reason to even have it in there in the first place. This should never have even gotten to this point. Okay? So, yes, change it. It's not that hard. And if you have unit tests in place, you would be able to pick up rather quickly if you did something that caused things to break unexpectedly. The memory allocation, we're talking bytes. We have gigabyte, exabyte machines. Why would you even care about this, Jason? And you're right. This is going to be such a minor blip, nobody's going to notice. But then again, it doesn't need to be done in the first place. And maybe somebody could look at what I did and said, hey, why don't you do this? Maybe this could make it even quicker or even less allocation, possibly. Okay. But the point is, just by doing it the way that I had here, you don't use any of that parsing stuff. You don't use any of that code. You simply do GUID.try parse. Okay, and things get better. This, I know this may sound a little ranty, and it's funny because way back many years ago, there was a site called angrycoder.com. And it's not around anymore. I have no idea where the URL goes, so buyer beware if you try to go there. It was a site that was created by somebody, I think his name is Jonathan Goodyear. Kind of along these lines of, this is frustrating as a software developer. And so I wrote a bunch of articles. I still have them. I might at some point throw up the content on my site just, for historical purposes. But where I would find pieces of code in an app and say, why are we doing it this way? And that got me a reputation a little bit with some people making fun of me, going, oh, you think you're the best coder in the world. Everybody else is making mistakes. You're the one that never makes a mistake. And, you're being really picky about things and blah, 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 on and on and on. Yes, I want to do better. And it does make me angry when I see stuff like this. Or even far worse. I've now seen at least 2 places where they went service nuts. Everything has to be a service. Everything has to be a service, and services are calling services, and we're caching data, and we're doing events, and all this is good. And I know somebody's going to say, but we've done that where I am, and it's all successful, and it's awesome, and we have everything in place. Great. Again, I'm not saying that that stuff is wrong, but what I am saying is I don't know how many times I've seen now where people are not optimizing or even looking remotely at what their queries do because they're using something like Entity Framework. And, oh, it's really simple to build a query this way. So, and hey, it works against my test database. So, yay. Never even bother to looking at the query plan. Never even thinking about what happens when we get more data in the database in a production system. And, oh, whoops, this really didn't scale well at all. This sucks. This is horrible. And not only did we do that, but we're returning so much data where we literally needed 2 pieces of information, like a first name and a last name. And yet this service, because we built up all these other services to get all this other information, and we can just compose and build off of these other things and reuse them. Yeah, but you did all that. You needed 2 pieces of information. So they're amassing all this data in memory and causing all these network calls to happen. And then they're also doing things where they're in for each loops, calling a service one ID at a time, and then they may do 5 things with that value. So they're incurring all this network overhead to do this stuff, never even thinking about, well, wait a minute, couldn't we possibly do this all in one shot? There's so much of an emphasis on, we got to get it done fast. We got to get it done fast. We got to get it done now. We can't, well, the business is hammering on us. We got to get this done now. Fast, fast, fast. Go, go, go. Well, we'll clean it up later, even though everybody knows what a farce that is, because that will never happen. No, it never happens. If there isn't support out of the gate that developers can take the time and the care that they need. And I'm not saying we need to take months to write a piece of code like this. That is not what I'm saying. What I am saying is writing software is not easy, no matter what some people will say. It does take time. It takes time to do it well. We have to review it with people. We have to write the tests to make sure that it's doing what I expect it to do. Okay. What happens if we get bad data? Are we defensive against that? All these other things that can happen in an application. And I fear that we put too much emphasis on saying we've got to get done in 3 days with this, rather than saying this might take 5 days or 2 weeks to get done. But when it does get done, it's going to be solid, it's It's going to be performant. It's going to be maintainable. It's going to be scalable. Okay. And again, I say that I know there's going to be people out there that are going to respond with, I can do that in one day and write all that, and you suck, Jason. What's your problem? Okay, well, I'm just going off of the experience that I've had. And it's not even with what I've seen with people that I work with. This isn't something that's against the company that employs me. This is just things I've seen at many different places in my life. So this isn't isolated, is what I'm getting at. This isn't something that I think just, happens with one or two people. I mean, I've seen this so many times throughout my career where I look at code and I'm like, why is it written this way? Why is it done this way? Why are we not testing what we do? So this set me off. This definitely set me off. That's why I wanted to write all this and do a video on it, because I think it's important. And it's not, and my career has been not just mostly, really all in the .NET world. I would bet that this is not limited to just people who code in .NET or C#. I would bet that this type of stuff happens in all sorts of languages, in all sorts of environments. And I know it is because I've talked to people who have told me about some of the stuff that they've had to unravel and unweave and unwind to get it in a better state, where it's already pushed to production, it's already in there. Why are we going to spend more time and money fixing this when it already works? That's I have to admit, that's a hard sell. People don't want to spend money hearing from developers that, well, what we have out there, we could do much better. Why didn't you do it good in the first place? I see people building this bridge over there, or this bridge over here has been up for 50 years. They didn't build it and say, hey, we can make it better. But you build a bridge, you're maintaining that thing all the time. Any bridge of any appreciable size has constant maintenance on it, constant diagnostics, constant testing on it to make sure what the state of the bridge is. Maybe they have to, paint it every 2 or 3 years. Maybe they need to, change some of the things that are on. Again, coffee is lacking. The thingies on the bridge. Now they have to sample the bridge to see if there's been any corrosion. It goes on and on. With a fair amount of bridges that you see on highways, they're not getting that kind of maintenance. Maybe they should a little bit more, but the large bridges, the ones that span for hundreds, if not thousands of feet, they need to get more overview. But that's what we should be doing. We shouldn't push something into a system and go, wow, that's really bad. We're too much in the mentality of coding is simple, developers are cheap, and we can get this all done yesterday. It's done. It's good. It's in there. And why complain about this? Buy more hardware. Buy a faster CPU. Buy more memory. Get a bigger hard drive. That's cheap compared to human labor. Yes, but that doesn't mean we did it right. We can do better. And this is just indicative and reflective of this kind of mentality. And we have, when we see things like this, and we see whether I did it or somebody else did it, and go, hey, why did you do it this way? And then say, why not do it this way? Provide a solution. It's one thing if you review somebody's code and say, that's stupid, that's awful, what kind of developer are you? That's dumb, fix it. Okay, first of all, that's not constructive criticism. That's gatekeeping. That's arrogance. You can look at this code and say, you don't need to have all this machinery in place. What you can do is this, because it will have less memory consumption and it will be faster. One of the things I find that's so enjoyable from the .NET team these days is when they release a new version of .NET Core, they've published all the things that they've done to improve the performance of the runtime. And it's very enlightening to see. And one of the things I've noticed from them is that, yes, sometimes they do some fairly big changes. More often than not, it's a lot of little changes, a lot of these little paper cuts that they kick in. And just start to bring down the memory pressure, start to bring down the amount of CPU cycles they need. And you could say, well, why didn't they do that in 1.0? Well, it's a different area, so to speak. It's a runtime that all this other code's going to run on. So yes, it has things that will be hit potentially a lot. And, their team is not of infinite resources. They only have so many people, and they do have to make sure that they're hitting areas that go, oh, we could probably do this. And then they have it open source, so they can get contributions from people. So the point is that it's also getting improvements over time. We shouldn't shy away from that. We shouldn't, if we ever say we're in an application and we can't do a change like this because we don't know if it's going to break anything, that is also a huge red flag in my book. If you don't know that a change has any impact because you don't have any tests in place, you're not in a good situation. I mean, there's no way around it. You're not in a good situation. So that also comes along with the ride, is being able to find code and go, oh, I could probably do this better. And then, as you've seen in a lot of, if you watch my videos in the past, you'll see that I say this all the time. I can change this, run my tests, and get a really, really good indication if I broke something or not. I'll leave on this point. I've been getting a couple of pull requests on my editor config generator library, and one of them came in yesterday and fixed a very minor thing on one of the configuration setting analyzer things. Okay. The point is that it was a one-line fix, but there were no tests added. And so I said, okay, I think this is fixing what you think it's fixing, but please add a test for this. And they did. They came back and they added a test right away. But that kind of surprised me a little bit. There's tests in here. Why didn't you add one? If you're going to add functionality to the app, if you're going to add just even a little thing, there should be a test that covers this case now. Okay. So, I'm going to stop here because I'm at my time. I realize this might have been a little ranty, but that's okay, because I wanted to get this off my chest. I think we're spending too much time on the terminology of the moment, making sure that we're covering all the buzzwords, but we're not putting the care and the time into actually making sure we have implementations that will support all these buzzwords. You can't just say, we're cloud native, woohoo, and have this kind of stuff underneath the scenes that's implementing it all. Okay. We can do better. And the we is me, you, everybody. It's not just me saying everybody else is bad. No. We can all do better. And we should support each other, teach each other. If we see something that we think somebody else is doing that's not the best, just say to them, hey, Why not do it this way? And then on the other side, be open to listening to criticism and suggestions and go, yeah, you might be right. Or if you think they're wrong, have the evidence to back it up. Okay? But have a rational, thoughtful discussion about these things. So that's all I'm going to spend time on today. Thank you very much for listening. Leave comments and questions below. See you in the next episode.